A half-mile wide rock just proved that everything we thought we understood about how our solar system formed might be fundamentally wrong. Not slightly off, not a small correction to an existing model. Fundamentally wrong. And the part that nobody is saying loudly enough is that NASA did not even plan to make this discovery. They were running a test, a warm-up, a rehearsal for the real mission that hasn't even started yet. What Lucy found during 2 flybys that were never supposed to matter changed the conversation in planetary science more than any planned experiment had in years. And right now, on August 20th, 2026, Lucy is still out there, still moving, still closing in on targets that no spacecraft in human history has ever reached. This is the story of what it found, and what it means for everything we thought we knew about where we came from. First, you need to understand what Lucy actually is, because this mission is unlike anything NASA has attempted before. Lucy launched on October 16, 2021 from Cape Canaveral. It is named after a famous fossil, a 3.2 million-year-old skeleton of an ancient human ancestor discovered in Ethiopia in 1974. That fossil was called Lucy, and just like that skeleton gave scientists an unexpected window into the origins of the human species, this spacecraft is designed to give scientists an unexpected window into the origins of the system itself. The logic is brilliant. Asteroids are time capsules. They have not changed in billions of years. They preserve the chemistry, the structure, and the physical conditions of the earliest days of the solar system, back when planets were still being assembled from dust and rock and catastrophic collisions. Studying them is almost like reading a history book, not the history of a country or a civilization, the history of everything. Lucy is planned to visit 11 asteroids over a 12-year journey covering roughly 4 billion miles. No spacecraft has ever attempted to visit this many asteroids in a single mission. Its main targets are something called Jupiter Trojans, a population of asteroids that orbit the Sun in 2 massive swarms, one leading Jupiter and one trailing it, locked in gravitational harmony with the giant planet. These objects have never been visited by any spacecraft ever. Scientists believe they are among the most primitive, most unchanged remnants of the outer solar system's formation. Lucy is heading there, but on the way, it had a couple of stops to make. And those stops changed everything. The first stop was an asteroid named Dinkinesh, and here is where the story goes somewhere nobody expected. Dinkinesh was added to the mission very late. It was not originally on the itinerary at all. Scientists spotted it as a potential target because Lucy would be passing close enough to get a look, and they decided to use it as a test run, a way to practice the systems Lucy would need when it finally reached the big targets. Dinkinesh was chosen precisely because it seemed boring. A half-mile wide rock sitting in the main asteroid belt between Mars and Jupiter, the kind of object you point a camera at to calibrate your equipment before the real show begins. Nobody expected it to matter. On November 1st, 2023, Lucy flew past Dinkinesh at a distance of about 270 miles, close enough to capture detailed images. The encounter lasted only minutes. The science team, back on Earth, waited for the data to arrive, expecting routine confirmation shots. What they got was one of the most surprising images in the history of planetary science. Dinkinesh was not alone. Orbiting it was a moon, a satellite, a small companion rock that no Earth-based telescope had ever detected. Scientists named it Selam, an Amharic word meaning peace. And like and subscribe right now, because finding a moon was just the beginning of what that data contained. When more data came in and the team looked more carefully at Selam, they realized they had not found a moon. They had found something that had never been discovered before in the entire history of space exploration. Selam was not a single object. It was 2 separate rocky bodies gently pressed together and fused into one, orbiting Dinkinesh as a single unit. Scientists call this a contact binary, 2 objects that collide so slowly they cannot shatter each other and instead simply stick together like 2 pieces of dough pressed into one. What Lucy had discovered was the first ever confirmed contact binary satellite of an asteroid. A moon made of 2 moons fused together orbiting a rock that nobody thought was worth looking at carefully. This had never been seen before, not once. In all of human space exploration, across every flyby, every orbiter, every lander humanity has ever sent to any object in the solar system, nobody had ever caught a contact binary orbiting another asteroid. Lucy found one on its very first flyby, during a test run, at an asteroid that was chosen specifically because it seemed unremarkable. But it gets stranger. When scientists analyzed the full dataset from the Dinkinesh flyby, the story of how Selam formed turned out to be stranger than anyone had guessed. Dinkinesh itself showed 2 specific geological features, a long trough running along one side and a ridge running along its equator, like a belt of rock piled up around the middle. These 2 features told a story of violence. At some point in the past, something caused Dinkinesh to spin too fast. The leading theory involves a process called YORP, a subtle but relentless effect where sunlight hits an asteroid unevenly and gradually changes its rotation rate over thousands or millions of years, like a slow, invisible hand spinning atop. When Dinkinesh spun too fast, roughly a quarter of its mass broke away. That breaking created the trough. The loose debris flew outward. Some fell back and formed the ridge. Some drifted into orbit, where over time it gathered into two separate bodies that eventually fused into Salam, an entire miniature world born from one asteroid, shaking itself apart through sunlight alone. The paper describing all of this was published in Nature in May 2024. The scientific community paid attention, but they had no idea what Lucy was about to find at the second stop. The second asteroid was named Donaldjohanson, named after the paleoanthropologist who helped discover and study the original Lucy fossil in Ethiopia. The naming makes a beautiful kind of sense. The spacecraft named after the fossil visiting an asteroid named after the man who found it. On April 20th, 2025, Easter Sunday, Lucy swept within 960 kilometers of Donaldjohanson at roughly 30,000 miles per hour. Even so, it collected images and spectral data of extraordinary quality. What came back to Earth over the following days rewrote the book on this particular rock. Start with the shape. Before the flyby, scientists knew from Earth-based observations that Donaldjohanson had significant brightness variations on a roughly 10-day cycle, suggesting it was elongated. They expected something lumpy and stretched. What they were not prepared for was the sheer strangeness of the geometry. Donaldjohanson is a contact binary, like Selim, two separate bodies that collided and fused, but the way the two lobes are connected is unlike anything science has seen before. The neck between them, the narrow bridge joining the two halves, is shaped like two ice cream cones placed tip to tip and nested together. NASA described it exactly that way in their official announcement. Two nested ice cream cones in space, stretching roughly 8.8 kilometers long and 4.4 kilometers wide, nearly the length of 100 football fields end to end. The rotation of Donaldjohanson is what truly broke the minds of the science team. Before the flyby, Earth-based telescopes had measured the asteroid rotating once every 10.5 days. Slow, but perfectly normal. What Lucy's data revealed was that the 10.5-day rotation was only part of the picture. The asteroid was also undergoing a second completely separate wobble around its long axis, a tumbling motion repeating every 26.5 days. Taken together, these two motions mean Donaldjohanson does not spin like a ball or a top. It tumbles through space like a football thrown by someone who had no idea what they were doing. Scientists call this a non-principal axis rotation state, and it means the asteroid is wobbling in a way that existing models had not predicted and that most asteroids simply do not do. Most asteroids settle into a single stable spin over time. Donaldjohanson has not. It is caught in a kind of perpetual physical confusion, rotating on two axes simultaneously in a pattern that defies expectations. This finding was published in the journal Science on June 18, 2026, authored by Dr. Simone Marchi, Deputy Principal Investigator of the Lucy mission. Three major unexpected findings at Donaldjohanson: the two-axis tumbling rotation, the ice cream cone neck geometry, and the third finding, the one that took everyone's breath away, was the chemical signature preserved in the rock itself. Lucy carries an infrared spectrometer. When it pointed that instrument at Donaldjohanson's surface during the flyby, it detected iron-rich clay minerals. Clay minerals do not form from dry rock. They form when liquid water interacts with rocky material over time. Finding iron-rich clay on a main belt asteroid that formed only 155 million years ago means that at some point in the history of its parent body, liquid water was present. Not ice, not vapor. Liquid water existing inside a rocky asteroid somewhere between Mars and Jupiter. To understand why this stops the world, you have to understand the question it connects to. Where did Earth's water come from? Earth formed in the inner solar system where temperatures were high enough to bake out volatiles. So how did Earth end up covered in oceans? The leading theory is that water was delivered by asteroid and comet impacts during the early solar system. And now Lucy has found direct chemical evidence of water, altered minerals on a main belt asteroid close enough to Earth's neighborhood to have potentially contributed to those ancient oceans. Scientists compared the clays on Donaldjohanson to those found at Bennu by NASA's OSIRIS-REx mission and at Ryugu by Japan's Hayabusa 2 mission. Both of those asteroids contained clay minerals too, but Bennu and Ryugu carry magnesium-rich clays, pointing to liquid water that persisted for possibly millions of years inside much larger parent bodies. The iron-rich clays on Donaldjohanson point to a much shorter water episode, a brief flash of liquid water chemistry in the interior of its parent before that parent was destroyed in a collision 155 million years ago. Each asteroid is a different chapter of the same story. Lucy just read a chapter that science did not know existed. Now pause and let this land. Lucy has made 2 asteroid flybys. Both were supposed to be warm-ups. Both produced discoveries that were, in their respective categories, the first of their kind in human history. A contact binary satellite, a double-axis tumbling peanut-shaped asteroid with ancient water chemistry. Both on practice runs. The opening acts, the real mission, the Jupiter Trojans. Johansson has not even started yet. Lucy is scheduled to encounter its first Trojan asteroid, Euripides, in August 2027, just 1 year from today, and everything about those Trojans, what they look like, what they contain, what they will tell us about the solar system's most violent and chaotic early period, is still a complete mystery. No spacecraft has ever visited a Jupiter Trojan. Scientists have theoretical models, but models are not the same as reality. As Lucy has already proven twice, reality tends to be stranger. The Trojans are believed to be among the most primitive objects in the solar system, darker, more carbon-rich, possibly carrying organic molecules that predate Earth itself. Some researchers believe they originated far beyond Neptune and were gravitationally captured into Jupiter's orbit during a period of massive solar system restructuring billions of years ago. If that is true, they are not just asteroids. They are messengers from the outer edge of the ancient solar system, carrying material that has not been seen up close by any instrument humanity has ever built. Right now, on August 20th, 2026, Lucy's cameras are being tested ahead of the 2027 Trojan flybys. The spacecraft has already photographed its Trojan targets from a distance, faint dots moving against background stars, still millions of miles away, but getting closer every day. The team at the Southwest Research Institute, NASA Goddard, Johns Hopkins APL, and Lockheed Martin are tracking it daily. Every data point that comes back is another piece of the solar system's biography. And based on everything Lucy has already found on what were supposed to be the unimportant warm-up stops, based on the double moon that should not exist, the wobbling peanut that defies the models, the ancient water chemistry locked in iron-rich clay on the surface of a rock born from a catastrophe 155 million years ago, the smart money says that when Lucy reaches the Trojans in 2027, it is going to find something nobody expected. It has already proven twice that the solar system is stranger than the models. The Trojans have been sitting in the dark, unchanged for over 4 billion years. Whatever is frozen into them has been waiting the entire time Earth has existed. Lucy is the first instrument that will ever get close enough to actually see it. And that is why, right now, this mission matters more than almost anything else flying through the solar system. Like and subscribe, because the Trojan flyby season starts in 12 months. And if the warm-up acts look like this, the main event is going to change everything.